All right. Okay, so letter A, an ad agency gathers information about the habits of Texas consumers who live in very small towns, less than 100 adults. They randomly select 12 of these small towns and then interview all of the adults in each of those towns. Which one would that be?
Cluster.
That's cluster, yep. Which part gives it away that it's cluster? There you go, right there. That's what I saw. All of the individuals, it's a census, right? So they randomly selected the towns and then it was a census after that. Good. Letter B, at the start of each shift, randomly select a number from 1 to 10. Choose that person as they arrive and then test every 10th person who arrives for work.
Systematic.
That's a systematic, yep. Every 10th, every 5th, every 20th, whatever it is, that's systematic. Okay. There are 4 employee classifications: doctors, medical staff, office staff, support staff. Randomly select 10 employees from each group. Stratified, good, stratified. Each of those is a strata. Each of those classifications would be considered a group. They're all doctors. It's a homogeneous group because they're all doctors. They're all medical staff. They're all support staff, and they're all office staff. D, Miss Hodge is curious about the number of hours that seniors spend writing their college essays. She numbers every senior and uses a random number table to randomly select 50 seniors and gives those seniors a survey to complete. Simple random, yep, SRS. SRS, simple random sample. Yep. She puts all of them in a hat and pulls 50 out. That is simple random sample, the best way to do it. E, a business wants to know what its customers think of a new product, and they think that men and women may view the product differently. A random sample of 45 men and 50 women is selected to complete a survey on the product. That's stratified again, yeah. Yep, stratified again. What were the strata based on? Gender, yep. No, yeah, it doesn't have to be equal. 45, like 50 and 50, no. Stratify, yeah. The main things of stratified are groups, and then I randomly pick from those groups, okay? F, the Podunk School District, which it wishes to give a survey to some of its middle school students regarding the quality of school lunches served in the cafeteria. From 15 middle schools in the district, 3 of the schools are randomly selected. The survey is then sent home to all of the students at those selected sites. That is a cluster again, yeah. That is an example of cluster. Yep. Okay, so that was review from 4.1. Now, 4.2 in your books is experiments. Now, when we talk about experiments, we're not talking about like chemistry experiments where you're mixing chemicals. It's not that kind of experiment. Experiments are done when you want to gather information about something. You want to test something, okay? You want to test a theory. You want to test a product. You want to test something. That's when an experiment is done, okay? So the first one is the difference between observational study and an experiment, okay? Observational study and an experiment. So observational studies, no treatment is assigned. Treatment is what I give you. So if you're in my experiment, I give you that product to use, okay? That doesn't happen in an observational study. No treatment is assigned, self-selection, okay? Merely observe a characteristic. So you're just sitting back and watching what's happening, analyzing the data. Perspective versus retrospective. Perspective means you pick your subjects and then you follow them around. Ask them questions as they're going through whatever they're going through. Retrospective means you pick your subjects and then you look at past records. So the people could have passed away already. Okay, they could have died already. You randomly pick them, and then you look at their medical records. Usually, if you're doing a observational study to test like some medical treatment. Okay, experiment is different. Experimental study, you give the person something. They wouldn't take it unless you gave it to them. Okay, so like for example, if you're testing the effects on a new pain relief pill, so like like Tylenol, you got a new Tylenol. If you're testing that, if you're experimenting on that, you have one group who takes that and one group who doesn't take it or takes a dummy pill, placebo pill, and then you compare the results. That's an experiment because those people wouldn't have taken that pill unless you gave it to them, right? Observe the response and measure its effect. So how is one group doing versus the other group? Well, this group, their headaches went away a lot faster than this group, okay? That's the response, okay? Measure its effect. So be careful when you're trying to decide whether it's an observational study or whether it's an experiment, because observational study is, they don't impose any treatment on you. They don't give you any treatment, okay? The people could be experimental study. So I'll give you an example. It's pretty common. It's pretty well known. And if it's not, I don't know where you've been for the last, since you were born, but cigarettes, smoking cigarettes, any kind, vape, cigarettes, any kind of that stuff causes cancer. Exactly. Exactly. Right? It causes cancer. That's verifiable, right? But here's the thing. There's never been an experimental study done on the effects of cancer. So how do we know it's true? On the effects of cigarettes causing cancer? What? Yes, we've only observed it. Only done observational study. So how do we know why? Why have we only done observational studies with determining the effects that smoking cigarettes or smoking any type of substance into your body?
It'd be unethical. It'd be unethical to like give somebody cancer.
What would the treatment be? Just having them smoke, right? Having them smoke. And if we know it already causes, it would be extremely unethical, right? So they have never done experiments, but they've done observational studies where they look at people who are already smoking. They randomly pick people who are already smokers versus people who are not smokers. And then they follow along to see how their data tracks. Well, these people over here who are smokers, they tend to have this, and this. These people who aren't smokers tend to not have those things. Some of them do, like my friend of mine. When you think of someone who has lung cancer, what's the main thing you think of? Smoking, right? Smoking caused it. I have a friend whose dad passed away from lung cancer 10, 15 years ago. Never smoked. Never smoked, right? It happens, but it's rare, right? It's rare that it happens. Most of the time, certain types of cancer are developed, it's because of smoking. And then you got things like emphysema, which is attacking your lungs, and you got different type of things. So most of the time, the vast majority of the time, that's due to smoking. That's why we can say smoking causes cancer. We can draw a line from smoking to cancer, okay? Now, does that mean everyone who's ever smoked will develop cancer because of it? No, right? But the chances of you getting cancer by being a smoker go way up, way up. First thing you do, if you ever tell if you ever say I smoke to your doctor, they'll be like, they'll look at you and be like, why? And then, because as a doctor, they've seen it so many times, right? Yes, they will. Okay. So here's the other thing though. If I want to be able to draw a line from one thing causes another thing, the only way to do that is by an experimental study. Okay, the only way to say this causes this is by doing an experiment. I can't do it with observational study. You can't do it. Okay, you can say that if this happens, this tends to happen, right? You can say there's a correlation there, right? But you can't say this causes this without doing experimental studies. So be careful with that, okay? So I guess technically we can't say smoking causes cancer, but there's so much evidence out there that it does, that it's kind of hard to ignore, kind of thing. And the reason why we can't do experimental studies with cancer, it's unethical. We can't give people nicotine. We can't make them smoke if they weren't going to smoke already. Right here in the experimental study, they weren't going to do that unless we asked them to. And if we ask them to smoke, got some issues there, right? Some ethical, what's that? They volunteer for the experiments, but you can't, even if they're like, oh yeah, I'll do it. You can't, you can't, yeah. Yeah, exactly.
Yeah.
So most of the time they've looked at past records where people are smokers, no matter, they were on their own. I didn't ask them to, they were on their own, and then see what happens, track them as you do there, okay? So a couple more. Observational study observes individuals and measures variables of interest, but does not attempt to influence the responses. Just sit back, see what happens. Experiments impose. When our goal is to understand cause and effect, experiments are the only way, okay? The distinction between observational study and experiment is one of the most important statistics. That's how we get our data. All that data that we have, that we've used, that we've crunched numbers, that we've used in our calculator, that's from here, from experimental studies and from observational studies and experiments. Okay, so that's how we get data. And then, okay, so a couple things. When you're doing observational studies or experiments, observational studies of the effects of one variable on another often fail because of confounding, what's called confounding, between the explanatory and one or more lurking variables. Okay, so a couple new words, a couple new terms there. A lurking variable is a variable that is not among the explanatory or response, but it's influencing the result. Okay, so something that I'm not testing is having an influence on the results. Okay, we don't want that, right? All I want to do is I want to make sure, does this pill make your headaches go away? Right? That's all I want. I want to know if this pill right here will make your headaches go away. If there's another reason why, that's what's called a lurking variable. Okay, that's what's called a lurking variable. So how do we get around that? We do things like randomly select groups. So if you volunteer for the experiment, I'll try your new Tylenol pill. Sure, I'll step up, I'll do it. What we do is we say, all right, I'm gonna have two groups. One group who's actually gonna get the pill, one group who's actually gonna test it, and one group who's gonna get what's called a placebo. What's a placebo?
It's nothing, but it just affects your mind.
Exactly, it's totally 100% up here. It looks just like the pill, but it's a dummy pill. It's got nothing. Sometimes it's a sugar pill. Sometimes it's like a water pill. Sometimes it just doesn't do anything, right? So you take it thinking, oh, I'm getting the pill, when really you're not, right? And then they measure, right? They measure the effects, right? The people who took the real pill, their headaches went away by this much. The people who took the dummy pill, their headaches went away this much. Well, obviously there's a difference in between those. What was the difference? The pill. We want it to be the pill, right? Now, if it's another thing, that's what's called a lurking variable. Okay, that's the lurking variable. Okay, we want to be able to draw a straight line from the pill, my headache goes away. If there's another thing, so we want to be able to draw a straight line from the pill to my headache goes away. Okay, if there's other things that are causing my headache to go away besides the pill, Those are called lurking variables, and we don't want those because it ruins our experiment. Okay. The other one is confounding. Confounding occurs when two variables are associated in such a way that their effects on a response cannot be distinguished. So these two are very much associated, okay? So confounding occurs when two variables are associated in such a way that their effects, let me see, on a response cannot be distinguished from another. So kind of like lurking, I can't tell the difference. I can't tell what's causing my headaches to go away, right? Confounded, I'm not sure. When I hear the word confounding, I kind of throw up my hands like this, like I'm not sure. That's what it means. I'm not sure what's causing it. I'm unable to distinguish the two, okay? So that's what confounding is. So those two go, that's why they're in the same green box. They're very much related, okay? Lurking variable is the actual variable. These things over here, these things out here that are causing. Confounding is the kind of the whole process. Okay, you're like, I'm confounded. I don't know what's causing it. Okay. So experiments, language of the experiments. A treatment is something you're given, the pill, the new, in the case that I was talking about, the new Tylenol pill. That's the treatment, whatever you're giving the person. Okay. Who are you giving it to? Person, animal, object, what are you giving it to? Those are called experimental units, okay? Most of the time it's a person, okay, who's volunteered to observe the response. The response is what happens when I give them this pill. Does their headache go away, or does their headache stay, or does it get worse? What's happening? That's the response, okay? Let's see. Sometimes when human beings are used, they don't call them units, they call them subjects. Okay. So experimental units, when they're when they're humans, sometimes they're called subjects as well. Okay. Let's see here. Okay, so unit, single individual, or it's called a unit or a subject sometimes. So subject. Okay. Factor. The factor is the explanatory variable. What is being given to you? Whatever is being given to the subjects are factor. It's a factor. Sometimes there's multiple things being given to people, multiple factors. Okay. A level is a specific value. Sometimes when you're given a new pill, 10 milligrams, which we're going to give this group 10 milligrams. We're going to give this group 20 milligrams. We're going to give this group 30 milligrams. And we're going to give this group the dummy pill, the placebo. Okay. So if there are levels, that's what it's called. It's a specific value of the factor. Okay. Sometimes they just say, we're going to give everyone 10 milligrams. Sometimes they want to break it up. Okay. Treatment, obviously. Treatment is a specific experimental condition applied to the units made up of factors at different levels. Okay. So the factors are the different things being given. For example, with my example of the new Tylenol pill, the new aspirin, right? Different factors could be like, okay, I'm going to give this group, I have 3 groups. I'm going to give this group over here the new pill. I'm going to give this group nothing. I'm just going to go send them to a dark room that's quiet, let them put their head down for 15 minutes and see how that works. This group over here, I'm going to give them the placebo pill. Looks exactly the same, but just nothing, right? So the treatment would be the pill, and the treatment would be putting them in their room for 15 or 20 minutes, dark and quiet, putting their head down, right? Those would be the 2 treatments there. Those would be the factors, okay? That's sometimes you can have multiple factors, is what I'm trying to say, okay? And then if you use different levels, different milligrams, That would be different levels. Response variables, what you measure, okay? These are the things that, so we're gonna be designing experiments. We're not gonna be doing any experiments. We're gonna be designing experiments. What would be a well-designed experiment? So when you're writing about them, be specific. What are we measuring? What do we wanna know? Well, if it's a Tylenol pill, if it's an aspirin pill, I wanna know if their headache went up or down, okay? So I would measure that some way. Okay. All right, so here we go. Example number 1. So what I want you to do is read this experimental setup. It's a setup of what they're doing, and then tell me what each of these is. Okay, I'll give you about 3 to 5 minutes to figure out what are the units, what are the factors, levels, response variables, what is the response variable, and how many treatments are there. Okay. All right, so a farm product manager wants to determine if the yield of a crop is different when the soil is treated with 3 different types of fertilizer. 15 similar plots of land are planted with the same type of seed, but are fertilized differently. At the end of the growing season, the mean yield from the sample plots is compared. Okay? So who or what are the experimental units? Not the plants, not the seeds. The soil, the actual soil, the land. The land is what they're testing, right? So you can say the plots of land or just the land. Okay. Factors. Factors are the treatments, right? What are the treatments being given? Fertilizer, yeah, the fertilizer. The type of fertilizer. Okay, the types of fertilizer. Levels. Levels are there different levels of the factors? It doesn't say, but what is it? It says right here, there are 3 different types of fertilizer, right? So we would say 3 levels, 3 types, 3 levels of fertilizer. 3 levels, so that would be, call them A, B, C, 1, 2, 3, whatever you want to call it. Response variable, what are we measuring? At the end, what am I measuring? The yield, right? The yield of crop, yeah. The mean yield right here. How much crop they're able to bring in from each of those plots of land. How many treatments are there? How many things are being given? How many? Only 3. There's 3 types of fertilizer being given, right? 3. Each of the fertilizers, each of those 3 fertilizers, that's all that's being given to the land. Okay, there are 15 plots, but those aren't being given, right? It's just the 3 types of fertilizers. Yes, I believe so. The levels and the treatments. Okay. All right, let's try this one now. A consumer group wants to test cake pans, to see which one works the best. The best meaning bakes more evenly. It will test aluminum, glass, and plastic pans in both gas and electric ovens. So fill out those for this one, for example 2. All right, so experimental units. What are the experimental units? The cake, yeah. So what is being, not the pan, right? So not the pan. The pan's going to be something else. What are the things being given treatments? The cake, yeah, the actual cake, yeah. The cake is the cake batter or the cake, right? Factors. So what are the treatments being given to the cake? There you go. That's where the pans comes in. The pans are one thing they're testing, right? The different types, and then the different ovens. And ovens. So levels. Exactly. There's two things, right? There's pans and there's ovens, right? So there's 3 levels of pans and there's 2 levels of ovens. So what would the number of treatments be? 6. So that would be here, right? The levels, there are 2 levels. There are 3 levels. Sorry, 2 different types. I'm not taking number. There's 3 levels of pans, and there's 2 levels of ovens. Now, when I put those together, there's 6, right? What am I measuring? How do I know if these pans and ovens are going to work? How evenly it bakes. Yep. How evenly it bakes. How evenly the cake bakes. Okay. All righty. Okay. So here we go. Now we'll get to experimental design. Experimental design. In 2007, deaths of a large number of pet dogs and cats were ultimately traced to contamination of some brands of pet food. The manufacturer now claims that the food is safe, but before it can be released, an experiment to test whether the food is now safe for dogs and cats must be conducted, right? So you see this all the time. Things are taken off the shelf, right? Usually it's the FDA who comes in and says they get word that, hey, these things, whatever they are not safe. So they make them take it off the shelves, fix it, and then we can put it back on the shelf. Well, in order to fix it, they have to show that it's no longer it's safe. It is now safe. Okay, so that's what the company has done. The company said, hey, we are now safe. So the FDA, the Federal Drug and the Food and Drug Administration, says, okay, we got to test it now. So in our experiments, if we're the FDA, what would the treatments be here? What would the treatments be? The new food that they claim is healthy, right? So the new food that they claim is healthy. You can't really see that. Let me change the color. New food that is now safe, or they say is now safe, right? That's what we're testing. That's what we're going to be giving the subjects. What would the response be? Sick, yeah, health. Health of the animals, health. Right? Okay, so at the bottom it says, I didn't make this up, okay? Deliberately putting dogs at risk at this experiment, but in fact, this is what they do. This is what they do with humans too, but what's the difference between humans and dogs? Humans have choice. I want to sign up for it. Dogs don't. Okay, so yeah, unfortunately, but it is that's what's done when they have to test stuff like that. Okay. Exactly. Okay. So we're going to come back to that one in a second, but before we come back to that, we are going to, these are the 3 principles of a well-designed experiment. So every well-designed experiment has to have these 3 things and has to have them explained. Okay, so this is the three things that you're going to explain. There has to be some random assignment. If I'm a person who wants to be in your medical, you're a doctor, and you're giving a medical, you developed a new treatment for whatever, and you need people to be in your experiment. I'll volunteer. Okay, that's great. But there has to be a random assignment. So usually this is what happens. Because I mean, like we were just saying, right? How do they get people to be in medical experiments? They have to volunteer, right? Pets don't have that choice, but we have that choice. We have to volunteer. It's not ethical, and it's not legal to make someone do this. So we have to volunteer. Well, isn't that voluntary response bias? It isn't until they actually are in the experiment, right? So how do we control who goes into what group? We randomly assign. Okay, so these guys are going to go get the real pill that we're testing. These guys are going to get the placebo pill. Okay, so they have no choice over that. Everyone thinks they're getting the pill, right? But in reality, about half and half are getting it, half are not. So there has to be some random assignment, okay? Impersonal chance to assign experimental units to treatments. There has to be some, and you have to explain where it is, right? How do we do random assignment? Well, you just did that with sampling, right? We randomly, simple random samples, stratified samples, all of those types of sampling methods we've used. That's how we're going to do number one. We just have to explain the process, right? How did you decide that these people are going to get the pill and these people are not going to get the pill? They're going to get the placebo. How did you decide? And more importantly, I don't want you to decide. What was your system for no human choice? Okay. Replication is the second thing you got to explain. Replication of the experiment on many subjects in different locations. Use enough experimental units in each group so that any differences in the effects of the treatment can be distinguished from chance differences between the groups. So for example, I have a new pill that's going to cure your headache better than anything on the market. So I get one person, I randomly assign them. I say, one person, you take this, you take my pill. The other person take a dummy pill. The person who took the actual treatment pill, their headache went away real fast. The person who took the dummy pill, their headache didn't get any better. Proof, right? It works, right? Why not? Why is that not proof? It works. It only happened once. I only did the experiment once, right? That's what replication goes after. Many, many times, many, many times. I don't want just one person, right? I want many, many different types of people. Males, females, people of different ethnicities, people of different ages, every types of difference. I want to get as many different people as possible so that I can show, if both of these people were men in their 50s, how am I going to say it works for females? Or how am I going to say it works for anybody else besides them, right? So replication is how we explain that, okay? You do the best you can. You just do the best you can. Yeah, that's a great question. If you only have people who of a certain, if you have a homogeneous group, there's not much variety there, right? You just do the best you can. Yeah, I think they have ways of doing that, but I'm not sure how they, but for us, just do the best you can with that. We just want as many people as possible. Okay. Control is the last thing. Control, we say control goes with the control group. Which one would be the control group? The placebo group, right? The placebo group, they're the control group. They're the control group because they're not given any treatment. It's just control that we say it because we can control that group, whereas the treatment group, I can't control. I don't know what's going to happen to them. The placebo group, I know what's going to happen. I'm giving them nothing. I'm literally giving them water. So nothing's going to happen to them, right? So we measure. That's what we measure with. One group we know is going to stay pretty steady here. The other group, I don't know how they're going to be. So we need to measure them based off of that. So explain for lurking variables that might affect the response, use a comparative design, control group. One of them has to be a control group, and ensure that the only systematic difference between the groups is the treatment administered. Make conditions as similar as possible for all treatment groups, aside from the actual treatments. So if I'm giving them a blue pill, I better be giving these guys a blue pill because they might talk. And one group says, oh, they're giving me a blue pill and it's round. Well, they're giving me a blue pill and it's not round. It's more of an oval shape. You know, things like that happen. So make sure it looks exactly the same when we're explaining it. Okay, if we observe a difference between groups, we want to know that it's the result of the actual treatment and not something else. As much as you think, well, how can these people, how can their headaches get better if I'm giving them a water pill? It will happen. It has happened and it will happen. It's called the placebo effect. Placebo effect is when you give someone a dummy pill and what you expect to happen to this group over here is actually also happening to this group over here, right? Their headaches are seeming to go away. Now, does it happen as much as over here? No. But still, the people over here, some of their headaches are going away. Why are they going away? I'm giving them water pill because the mind is a powerful thing. The mind is a powerful thing. Science can't explain it besides the fact that it happens. It's called the placebo effect. Okay, so it is real. So this group right here, their headaches, 75% of them, their headaches went away. This group right here, some of their headaches will actually go away by giving them a water pill or a sugar pill. Now, will it go up that much? No, but it'll still go up a little bit. Okay, it always happens. It's called the placebo effect. Okay, all right. So the next thing we're going to do starting tomorrow is we're going to do an experiment with these poor dogs. We're not going to actually do the experiment, but we're going to design the experiment. Yes, I know.
Animal rights.
That's why we're just talking about it and not doing it.
Imaginary animal rights.